Hello there. Welcome to our today's science lesson. The topic for the day being properties of substances. In our previous lesson, we looked at the introduction of science to year 7, and under that introduction, we saw so many things associated with the science and how well you can run yourself around in a class of science. We saw things to do with how to write a scientific report, how you should arrange for your own experiments, how well you are supposed to think scientifically, and all that associates itself with the science in the introductory bit of it. But in our today's lesson, we want now to look at this science, generally looking at the materials involved in science. Remember, in whichever way you will be carrying out an experiment, you want to write that report, you are thinking scientifically and all that, the materials you will be dealing with are materials that carry properties. These properties are in so many ways in terms of description, and that is what we want to look at. Now, if I can start with a question, have you ever asked yourself why maybe in an early morning hour or during some seasons, when you breathe out maybe fog? You have just washed your clothing. It is not a sunny day, but you find after some time the clothes are dry. Maybe you are walking just along a road and you see maybe the clouds appear at a certain time of the day, but not every time will you see large accumulation of clouds. What will be happening in the sky for such things to happen? Maybe you have seen during some seasons, or even general seasons depending on the area you are talking about, the ice floating on water. Icebergs may be breaking into so many small bits and they float on water, and yet water and ice are one and the same. It's only that one is in solid state and the other one is in a liquid state, and so many other questions. Those questions can be comfortably answered by looking at what we want to look at today, and that is the properties of substances. But now, to understand this issue of properties in a much better way, we have to categorize the properties into two. And that is, so we have two categories of properties, and number one being physical properties of substances, and the second one being chemical properties of substances. Physical properties and chemical properties. Maybe before I go into the details of each one of them, we need to know roughly the differences between these two, but I will go in detail of each and probably get to know in a proper way of understanding. So in general, physical properties is about what your eye can see, what your nose can sense, what you can touch. I mean, what your what your five senses can taste, can see, can feel, can be used to identify. Identifying these properties using any of your five senses. Such will be called a physical property. I can say the physical property of this item is it is white. That's a physical property. I'm using the sense of seeing. I can say the physical property of this pen of mine is smooth. Why? I'm using my sense of touch. I can say the physical state of this pen is odorless because it doesn't produce any smell that I can taste or I can feel using my nose. I can say the physical state of this does not produce any sound because I'm not getting it using my ears. And maybe, though not allowed in science, under very rare circumstances do we use that sense of taste. I can say maybe this item is tasteless. That is, I will have tasted it and it doesn't give any sense of a particular taste. That is physical properties. In addition to other things that we shall be describing further, but still you will be using your your senses that are commonly applied, and that is the 5 senses. But when we talk about chemical properties, this is how that substance reacts with others, combines with others. And remember, when it combines, obviously it will give us a different substances. A substance. Different totally from the original that had to react with the other substances. For now, I want us to look at the description of properties. Description of properties in physical way. Description of properties in physical way. Now, I will wish you look around. Try to look around, starting with yourself. Look at yourself. Look at what you are having. Look at your clothing, maybe your shoe, your seat, the floor, the building, everything around. Take your time. I'm sure you have seen so many items around you. Now, probably you have not looked at them scientifically. Remember, in our previous lesson we talked about thinking scientifically. So even if it is just an issue of observation, observe items scientifically. Now, I will still ask you to redo what you did, but now with the more insight of those items. Look at them in terms of their properties. Look at them, anything around, in terms of their properties. I'm sure you have done it a little bit different from the previous one. But the question is, when I say in terms of the properties of those items, what does it mean? I will ask you again to look at the items for the 3rd time, but now look at them in terms of the properties in relation to this. Properties like, does it conduct an electric current or heat? Can you easily break it? Is it brittle? Is it hard? Is it smooth? Can it flow? Is it fixed? Can it be smelled? And so many of all those properties you can ever think of. Can you redo it the 3rd time? I'm sure now you have seen the difference between just seeing like any other person and seeing with an insight, with the proper observation of whatever you are seeing. When you talk of observation, it means in addition to that seeing, you are synthesizing the seeing in terms of properties. You synthesize the seeing in terms of properties. You observe the inside of everything. That is how a scientist is supposed to observe issues, observe items, observe substances. Now that you have seen so many of them, and I'm interested for now in physical properties of all that you have just tried to identify right now. Now, looking at the world in general, because what you are seeing is what you have around you, but looking at the world in general, there are so many other substances that you haven't seen, observed, or even heard of. So all of those items included, we need to be able to describe them. We need to describe those substances. Now, when describing a substance, there are various basic ways you have to describe them. Various basic physical ways, not just ways, but physical ways. Remember, there's physical and chemical properties. So we don't want to look at chemical properties, chemical ways for now. We only want to limit ourselves to physical ways of describing that substance. What do you look at? As I've said, there are so many ways. So under physical ways of describing that substance, you need to look at one, you can look at the color. The color. What is the color of that particular substance? When looking at that color, be very specific to that color. You don't use the issues of ish, whitish, bluish. We don't describe it that way. You describe it as white, not whitish. Green, not greenish. That is not a proper way to describe color. But remember, by looking at color, that is a physical way of describing that particular substance, and it can be used to differentiate one item from the other. The other way to describe a substance physically is looking at the density. Looking at the density. Maybe I should mention it as mass, so that I use now density. Now, why I'm linking mass to density is because density describes how heavy or light a material is. How heavy or a material is, especially in respect, in our common way of understanding or our common way of operation, it is in respect to either air or liquid, like in water. You can say this item is sinking in water because it has a high density, or it is floating on water because it has a less density. But when you are talking about now, it has a high density or less density, you are in a way just looking at mass, because these two are directly related. You only need to add here volume, and you see the three relating to each other by seeing that mass is equals to density times volume. Mass is equals to density times volume. So as you can see, mass and density are directly related to each other. So you can describe a substance based on mass or density by saying this one is more dense, this one is less dense than the other one, or this one is heavier and the other one is lighter than the other one. The other way you can describe a substance is in terms of, is it an acid or is it a base? Most of the substances we interact with here on Earth, especially for those that are either in solution form or gas form, at least a majority of them, or those that have been crystallized, they are either acids or bases. So is it in any way one of these? If not, then we can put it in another category of neutral. But a majority are lined in terms of acid or base. Again, you can also look at it in terms of, is it a solid, liquid, or gas? that particular substance you are talking about. Is it a liquid? Is it a solid? Or is it a gas? So in terms of this, you are looking at the state at which that substance is existing at room temperature. The state at room temperature. And when we talk about room temperature, we commonly talk about 25 degrees centigrade. So the state at which that substance will be existing at room temperature, which is 25 degrees centigrade. In so doing, you will be able to identify a substance for a particular use. So this also brings out another way you can physically describe substance, the use. If you know this item can be used for this, then you can easily use that way of applying the substance to describe the substance as either maybe hard and all that, or soft, smooth, rough, whichever way. So what am I trying to say? You will find that in describing a substance, in most cases, most of these properties I've just, or descriptions I've just stated, will always be applied, because an item can have 2, 3, 4, or even all of them as characteristics associated with it. For example, if you are talking about a liquid, water, you are talking about water. Water at room temperature will be a liquid. But looking at its uses can also tell you that it is a liquid, because it does that property of flowing. It can be used maybe in transmitting pressure, which are properties of a liquid. If you look at it in terms of density, maybe if you mix it with a liquid like kerosene, the two cannot mix into each other, they are immiscible. So if it goes below, that is you are talking about now density. It is more dense than that kerosene. You can look at color, it is colorless. So you can say, since it is colorless, that's water, and it's different from this one which is red, probably that was a red paint, or that's blood. So you can also use all this just to describe one particular item, and so forth. Now, there is also another way of describing a substance that we commonly do, but some of the students who are young in science do not look at it to be one way of describing a property physically, and that is solubility of substances. Solubility of substances. When it comes to solubility, you have to note that we have commonly two types of solvents. That is polar solvent and non-polar solvent. We have polar solvents and non-polar solvents. So when you are talking about solubility, you have also to be very specific on which type of solvent you are interested in. Now, when you talk about a polar solvent are those solvents that are having positive and negative terminals in them. For example, when you talk about a polar solvent, you will be mentioning a solvent like water. When you look at the molecule of water, it has oxygen and 2 hydrogen atoms in it. These are things you will learn in detail as you proceed on with your science lessons. So water has oxygen and hydrogen atoms, and in being this way, just like if you have maybe a friend or you have a sibling, brother, sister, and you want to share something, then you agree that each one of you must donate something. If you want to buy maybe something to eat, you have a half of the amount, your friend has half of the amount. The two of you put the amount together so that you can be able to buy the item. But on sharing the item, your friend becomes a little bit skewed. Instead of sharing halfway, your friend takes a little bit more of the item than you. That one is common. It is common. It always happens. So in so doing, you will be having you being the lesser one, having less, and him or her having the bigger one, that is more. So if that item was to make one either more negative or more positive, I think it will have done. So let's assume the sharing of this bond, the sharing, these are bond, and this bond is made of two subatomic particles, which we will learn later, that what we call electrons. We call them electrons. So these electrons are two of them, but the two electrons are moved much closer to oxygen, than to hydrogen. Since these electrons are usually negative in charge, they make now generally oxygen to be partially negative, and if oxygen is partially negative, hydrogen is partially positive, This makes now in general water to be polarized, to have poles, the poles being the negative pole and the positive pole. So if this water is polarized, that is, it has positive and negative, then the substances to dissolve in it will also be required to have polarities. Like for example, when you talk about your common table salt, we call it sodium chloride. Sodium is positive, chlorine is negative. So it is polarized, and that is why that sodium chloride, which is common table salt, the one you now normally use in flavoring your food, when put in water and stirred, it will dissolve. But the same will not happen. If you use something like paraffin or kerosene. If you use kerosene, add in sodium chloride, however long you will take stirring, it will not dissolve. Why? Kerosene is not polar, but it is non-polar. Kerosene is not polar, but it is non-polar. Take the same, maybe paint. If you look at okay, we can still use paint as a common liquid. Now, you will find that you can use kerosene to dilute paint. Just to confirm to us that paint is non-polar, kerosene is also non-polar. But you cannot dissolve sodium chloride, that's common table salt, in paint, neither can you do it in kerosene. Why? This one is polar. So what does it show us? It shows us that non-polar will always dissolve in non-polar, and polar will always dissolve in polar solvents. So let's go back now to solubility as a general method of trying to describe substances physically. So using solubility, you can easily categorize a substance physically or describe that substance physically by saying this substance is soluble or this substance is insoluble. But I've said you have to be very specific by saying this substance is soluble in water or this substance is soluble in kerosene, so that anyone who looks at that description knows that the substance you are trying to describe is either polar or non-polar, depending on the solvent into which it was dissolved. So solubility is a very important part of describing substances. We can also look at another method, that is electrical or heat conductivity. This is also a method that can be used to describe a substance, but some don't look at it in that perspective. So here we are. We have to get it clear that it can also be used to describe a substance. Look around you. Can you try to identify? Now, that looking should be a proper observation. Synthesize the looking, the seeing. Are you seeing any substances that can be able to conduct an electric current? And are you seeing those that cannot be able to conduct an electric current? That is electric current and heat. Look around. For me, I can see window frame is made up of a metal. I've managed to see the frame of a seat. I don't know for you what you have seen. So the two items I've just mentioned are able to conduct an electric current or heat energy. But I also have other substances that I've identified, I've seen, and by analyzing I've observed that they cannot be able to conduct an electric current. An example is this one. This is a plastic material. Can it be able to conduct an electric current? The answer is no, it can't. So we can easily categorize substances into conductors and non-conductors. Those that conduct electric current, we call them conductors, and those that do not conduct as non-conductors of electricity. So conductors and non-conductors of electricity. That will be another way of describing substances physically. We can also look at it in terms of as much as we had already mentioned the issue of is it solid, liquid or gas at room temperature, you have just seen it is a solid, but you can go further. You can go further and look at it in terms of being hard. But again, in being hard, there is what we call being brittle or being just soft. Brittle or soft. Hard, in that hardness, is it brittle or it's just hard? But again, instead of being hard, we can also talk about being soft. That is another way you can describe physically a substance. So as you can see, all we have been doing is looking for ways on how to describe a substance physically. Trying to describe a substance physically. But in all those ways of describing the substances, there is one way that stands out to be very domineering, and that is the state of substances at room temperature. State of substances at room temperature. And remember, we said that room temperature is 25 degrees centigrade. So this is one of the methods to describe a substance physically, but as I've said, it is the most dominant way of describing substances. As I said earlier, substances can be categorized into three states of matter. Can be categorized into solids, liquids, and gases. So they can be categorized into solids, liquids, and gases. There is also another state of matter that we don't have it here on Earth, but it is seen or it exists in other planets, and that is plasma. Plasma. If you are to get it on Earth, then it will be when we have very powerful sparks. Very powerful, during very powerful sparks, like maybe during lightning, if a spark is generated during that, or you generate a machine that will be producing such, then you can talk about plasma. This is an air-like gas, or I can say a gas air-like, which exists at temperatures of about 6,000 degrees centigrade. So if you have a gas, and this gas is existing at temperatures as high as 6,000 degrees centigrade, then you will be talking about a special state of matter that we call plasma. But for our study, or our level of study as at now, we limit ourselves to these three states of matter, and that is solids, liquids, and gases. Now, we need to understand these three states of matter in a little bit more details, and also see how you can move from one state to another. How you can move from one state to another. So, from the statement of saying move from one state to another, it proves to us something, that when you are talking about physical properties of matter, you are only talking about properties that can change one item from appearing in a particular manner to another format, but not changing the original arrangement, the original existence of that substance chemically. It remains the way it was originally chemically. It only changes the physical formats of the same item. And one of it is when we look at the state of matter, that is the state of the substance. Substances are just matter, and having ways on how to move a solid to a liquid, liquid to gas, and vice versa, then we shall be saying that you can easily transform a substance from one state to another physically, but still maintaining the chemical composition of that particular substance. So to start off, let's first of all know what is a solid, what is a liquid, and what is a gas. In addition, we'll see the properties of those items in these three states of matter. So for an item to be called a solid at room temperature, it must qualify by having the following characteristics. One, it must have fixed shape. It must have a fixed shape. Look at this mark pen. Even if it takes a whole year, you will still find it this way. Why? It is fixed. And fixed what? Fixed shape. Because it is existing in solid state at room temperature. Fixed state. What else do we see? We can as well use this one to state it. Can it be compressed? It can't. So solids cannot be compressed. Cannot be compressed. Looking at other characteristics just pertaining this, when you look at a solid, can it move from one point to another? If I place it here, it will remain at the same position forever. So it is in fixed position. Fixed position. Fixed position. Again, what you also see around, because remember we are looking at what we always interact with in our common daily ventures. You will find that most of the solid items you interact with are heavy. Relatively heavier in comparison to their other states of matter-based substances. So they are heavy, That is, we look at the mass. By mass, they have more mass compared to other substances. So, if these are the properties, do you think the same properties describing the same property in relation to a liquid will be different? Let's see. So this one was for solids. Let's look at for liquids. We have only picked out a few. We can't mention everything. So these are just a few characteristics on how to state whether a substance is a solid or not. So let's look at it in terms of describing a liquid, but in relation to these 4 points of ours. So fixed shape. Do you think liquids have a fixed shape? If maybe you happen to have a bottle of water, maybe where you are seated, or you are taking maybe some kind of beverage, a drink, look at it, try to shake the container. What are you seeing? I'm sure you are seeing that liquid changing the shape. The liquid is changing shape. So what does it tell us? For liquids have no fixed shape. They don't have fixed shape. Secondly, being compressed. If you have a liquid and you happen to get something like a balloon, pour in the liquid like water in a balloon, make it very tight, using maybe a string to tie it so that it is fully engorged in that part of the balloon. Then try to compress the balloon. You will find that it can never allow the compression to happen. Just like, for example, I'm sure you at one time you must have done this. You have blown into a balloon when it is still small. If you compress it, if you hold it in your palm and compress it, it will allow you to compress it to a little bit smaller size. That does not happen for water. So what does it tell us? Cannot be compressed. Cannot be compressed. Let's look at position. In relation to position, go back to that container of yours. I don't know what it was. I don't know what liquid it was, but try to shake it if at all you have it. And if you don't have it, after the lesson, go try and see if it is real with what we are trying to talk about. So when you shake, I'm sure you have seen the position of the liquid changing with the time as you shake the container. What does it tell us? It tells us that for liquids, they are not in fixed position. They are not in fixed position. Not in fixed position. But there is a further description we can add to this point of ours. If you happen to get 2 containers holding the same liquid, and those 2 containers are of different shapes, do you think the shape of the liquid will be the same? Obviously not. The liquid takes the shape of the container. So you have to add the statement here that not in a fixed position, but takes the shape of the container. Takes the shape of the container. That's very important. So that you differentiate between not being just in a fixed position, but also being able to move around until it occupies all the areas of the container. Then lastly, in terms of mass. Now you will realize that, as I said, most of the items we interact with, those that are in solid state, are always a little bit more heavy than those in a liquid state. But this does not apply to all or in all cases. You will always find liquids being a little bit lighter than solids, but not in all cases. Let's take an example here. I stated earlier that ice will always be found or will always be seen floating on water. Which of the two is a solid? And which one is a liquid? Water is a liquid and ice is a solid. But it is the ice which is in solid state that is floating on water. So in such a cases, there are special ways on how we can be able to explain that. And that will depend on density. Remember, we also mentioned density as a way of describing properties of substances. So when water is at 4 degrees centigrade, when water is at 4 degrees centigrade, it has the highest density. It has the highest density. And when you look at ice, whether it is an iceberg or whatever, so long as it is ice, the temperature will obviously be 0 degrees centigrade and below. 0 degrees centigrade and below. So being that it is not at 4 degrees centigrade, the density will be less. The cohesion of water molecules is highest at 4 degrees centigrade. Above 4 degrees centigrade, the molecules are a little bit far away. Below 4 degrees centigrade, again the molecules are a little bit far away. Because of that, being far away, it makes that water or that ice to be less in terms of density, and water at 4 degrees to be high in density. So the one that is less in density will float on the surface of the one that is in high density. But that is a unique case. For most of the substances, liquids will always tend to be of less mass or less density than those that are in solid state. So that's all to do with the liquids as per the 4 points. Remember, there are so many ways you can still do it in terms of description, but we are only limiting ourselves to these 4 points. Let's look at gases. When you're looking at gases in relation to the 4 points, and also remember the 4 points of the solids, now we have the liquids, so we want to link it to the 4 points, but in gas state. So starting with the first one, have no fixed shape. For solids, we said they have fixed shape. Do you think gases have fixed shape? That one I cannot ask you to look around because you cannot be able to see a gas. But when described in terms of color, then you can be able to see a gas. But you can observe the gas. Now in which way? If it is colorless, like now air, you can observe it through feeling. You can feel it is windy. That is a way of observing the gas. Now, as you are feeling that air, do you think it has any particular shape you can describe that it is now oval or it is maybe rectangular? No. So we can have our first description here that have no fixed shape. So just like water, they don't have a fixed shape, and instead they take the shape of the container. So it also applies to the position of the gas. Now the second point is to do with the compression. Do you think a gas can be compressed? And for you to answer such a questions, just like what we learned in our previous lesson, always think scientifically. With the point, try to synthesize. So, can you think of a situation where a gas is being compressed, so that you will qualify our point that it can be compressed or it cannot be compressed? I can give you an example of pumping air in a bicycle tire, motorbike tire, vehicle tire, or a ball. I'm sure you have once been involved in any one of them. Now, when you are pumping that air in that ball so that it is hard enough for you to play around with, do you think when you did it, just the first push, was the air inside enough to fill the whole space in the ball? If this was the size of your ball, the tube in the ball, then you only pushed in air at once. Do you think the small amount of air you had pushed is enough to fill this ball, the tube of the ball? The answer to it is yes. And this one is going to describe to us the position. So I'm going to use this to answer the compression and the position of particles in a gas state. So you'll find that particles in a gas state, once they have been injected to a particular container, they will always spread to all direction until they fill all the area that has been allowed to be filled. And to confirm this, we can use a perfume. If one of you entered your classroom with a particular perfume, get seated maybe at the back of the class, how will these other students seated in front of the class realize that somebody has come in? And probably if you know the perfume, you can even easily state out the person and say, Fulani, this kind of person has come in by name. John has just come in. And yet, you didn't look at the back to see if that was John. What did you use? You used a gas that moved from one particular position where John had to take a position of sitting, spread to all parts of the classroom until all the classroom is filled up with the same type of perfume. That just shows to us that position of gaseous particles is not fixed. Position of gaseous particles is not fixed, just like for the case of liquids. But in terms of compression, after it has filled the whole space, is it possible that you can add in another injection and another one and another one? Yes, you will do so until it reaches a time whereby the pressure from inside and the pressure from outside, because of the outer hard covering of the ball, are almost equal. They are almost equal, then it will not be so easy for you to inject in more air. This confirms to us that air or gases can be compressed. Gases can be compressed. That's why you are able to add in more air as you are pumping that foot pump or whichever type of pump you are using to put in that air to make sure the ball is to the right toughness as you want. So again, the fourth point, which was in terms of, which was to do with the solids, but for the gases, I didn't indicate it here. It was in terms of looking at a solid particle, looking at solid particles which was easier to be described in a solid state, but it was a little bit harder to describe by writing here in terms of liquids. And the same applies to gases, because the particles in gas are mobile, particles in liquid are mobile, but particles in solid are in fixed position. So what you have just been doing here is to differentiate between these three states of matter: solids, liquids, and gases. So in differentiating, we have also been, in a way, defining what is a solid, what is a liquid, and what is a gas. Now, we also need to realize that by looking at solids, liquids, and gases, we can apply, or we can look at the aspect of use. We can look at the aspect of use to know whether the substance that is inside a particular container, probably you have just been given a container having something in it, but you cannot be able to see using your eyes to see what it is. Is it possible that you look at the use and try to identify or categorize it into the three states of matter? The answer to it is yes. For example, if you look at a tire, you haven't been able to touch it so that you can know whether it is hard or not. Is a solid, a liquid, or a gas? By looking at it, carrying all that weight of a vehicle or whatever the machine that is being used to carry, if that item is so heavy to be carried, do you think a gas can carry it? Do you think a liquid can carry it? I'm sure not. It's only a solid that can carry it. But here also comes another question. If this item is filled with something inside, if this item by the name a tire is filled with something inside, how will you tell whether the item inside is solid, liquid, or gas? You look at the ability to be compressed. If it is filled by a gas, you will find that if this tire goes over a hard substance like a stone, it can easily be pushed inside to show that whatever is inside can give an allowance to be compressed. But assume this tire is made of a metallic substance. We know of tires that are metallic. If it goes over a stone, will the same aspect of being pushed inside take place? It won't. That will have confirmed to you that because of the use and how it has behaved on being used, you can easily tell what it is or what is it that is inside that particular substance. So use is also a good way to describe these solids, liquids, and gases, which will still be describing the same properties we have been looking at, like being compressed or not being compressed. Now, we also need to know that we can easily be able to change one state to another. So, if we have a solid, we can change it to a liquid, and a liquid to a gas. And we can still do the reverse of the same. We need to know these types of processes, because remember, this is only an issue to do with the physical change, but not chemical change of these particular items. So we have to identify the physical processes that are being involved in changing of these states. Let's start with the solid to liquid. What could be the name of the process involved in changing solids to liquids? The process is melting. And what should be done for a solid to change to a liquid in a process we are calling melting? That is heat energy. You have to add in heat energy. So by adding in heat energy to a solid, you make the solid to change from solid to liquid. The process of doing so is called melting. The same happens to liquid to gas. You have to add in heat energy. And when you add in heat energy, the liquid will change to gas in a process we call boiling. And in the boiling, you cause what you call evaporation. And in evaporation, you'll have turned a liquid, for example, water, into a gas. But we also have the reverse. And the reverse is, here we talked about addition of heat energy, and here there is subtraction of heat energy. We can say cooling, when you do cooling. When you are cooling, you are only but subtracting heat energy or reducing or removing heat energy from a particular substance. So when you subtract heat energy, that is in a process of cooling, a gas will change to a liquid in a process called condensation. In a process called condensation. Cooling will have caused a gas to turn to a liquid. Now from a liquid to a solid, the same, it is a subtraction of heat energy or doing further cooling. You are just doing further cooling. Now what will be the process? Is it the same condensation because it is minus heat and cooling? No. This one is called freezing. It's called freezing. Now what you need to realize is by using these four processes, that is melting, boiling, condensation, and freezing, you can also be able to identify a substance physically. How? You need to realize that all the substances that will undergo these processes do not undergo the processes at the same temperature. Do not undergo the processes at the same temperature. So if you can take water as an example, to turn from solid to liquid, you need to heat the solid. You need to heat the solid until it reaches 0 degrees centigrade. Until it reaches 0 degrees centigrade. But remember, this one should be done at sea level. At other levels of height, we can easily see some other effects. Because remember, at sea level, we shall be talking about also the atmospheric pressure being 1 atmosphere. If you reduce or increase atmospheric pressure, you will also affect these processes. So the temperatures I'm quoting here are with respect to sea level, where we have the atmospheric pressure being 1 atmosphere. So at 1 atmosphere, then we shall see at 0 degrees centigrade, solid changing to liquid in a process we are calling melting. The same will not happen to all other liquids. Talk of mercury, ethanol, and so on. Liquid to gas, we can talk about 100 degrees centigrade. Still remember, at sea level. The same temperature apply to the reverse. If the gas was at a temperature higher than 100, let's say maybe 120 degrees centigrade, even if you cool, but you are still above 100, let's say 101 degrees centigrade, it will still be in a gaseous state until you reach 100 degrees centigrade. Then going downwards is when it will change from gas to liquid. The same to this. Until you reach 0 degrees centigrade is when you will undergo the process called freezing. We have been doing a general analysis of substances that we always interact with, and in doing that general analysis, we are able to describe them physically, and by describing physically, we only use the physical properties, appearances of those particular substances. In doing so, you don't change the chemical composition of the substance. But when it comes to a point where chemical composition of the substance is changed, then such a property or such a description will be called a chemical property. In our next lesson, we shall look at chemical properties and all other things that may be associated with the chemical properties and maybe in some way also associated with the physical properties. Thank you.